An exploration of factorials and permutations. Smaller factorials can be calculated just in your head. So 2 factorial means 2 times 1, which of course is 2. When you see that factorial sign or the exclamation mark, that means you take the number and you multiply downwards down to 1. So 4 factorial, 4 times 3 times 2 times 1, which is 24. Some people have the ability to do 8 factorial in their heads. I do not. So it's 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. I have to use a calculator. That's 40320. I suppose if I was patient enough, I could do it, but I'm not that patient. So anything above a 4 or a 5, I would suggest you use a calculator. And now we have some large factorials, which you will definitely need a calculator for. So 21 factorial becomes 5.1091 times 10 to the 19th. 53 factorial is 4.2749 times 10 to the 69. And some calculators won't go above a certain value. Many of them won't go beyond that. 70 factorial, 79 times 10 to the 100. So this is just to reassure yourself that your calculator is functioning properly. Please just check each one of these and see if you get the same result as I'm showing on the screen. And now we're going to evaluate some factorial expressions. There's a couple ways to do this. You could figure out what 10 factorial is and write that down, and 5 factorial, and then divide those two numbers separately. But conceptually, here's what's happening. 10 factorial is 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And 5 factorial, you start at 5 and work your way down to 1. These numbers all cancel out, and you're left with 10 times 9 times 8 times 7 times 6, which will give you 30240. 30240. The second one, following the pattern of the first, becomes 83 times 82 times 81 times 80, and that value becomes 44, 102, 880. Counting possibilities. Now let's put this into practice. The senior choir has rehearsed 5 songs for an upcoming assembly, and how many different orders can the choir perform the songs? So you've got 5 songs. I like to use little lines here to indicate the different choices. The first song that the choir sings, the choir would have 5 possibilities to choose from. And when they choose their second song, having used up one, they only have 4 songs left to choose from for their second song, and so on down the line. So that is 5 factorial, and that value would be 120. Now let's turn our attention to something called the indirect method. That method means that you're subtracting the negative case, or what you don't want, from the total, and that will give you what you need. So our scenario is, in how many ways could 10 questions on a test be arranged if the easiest and the most difficult question are side by side in question A? So given 10 questions, Easy, hard are together. You've used up 2, and then you've got 8, 7, 6, 5, 4, 3, 2, and 1. So now I've illustrated 10 questions, with easy and hard being questions 9 and 10. When they are side by side, how many ways can we arrange our questions? Well, we link these 2 together, and it becomes one entity, and that leaves us 9 things to order, and we can order 9 things 9 factorial ways. What we haven't accounted for is we can also order it hard and then easy. So we have to multiply it by 2 factorial. The reason I'm using 2 factorial instead of just 2 is, for example, we could have 3 questions we want linked together, in which case there would be 6 possible orders, 3 factorial. And so you want to use that concept as you're illustrating these questions. So 9 factorial, 2 factorial will give you 725, 760 ways. To find the answer to B, where they're not side by side, we take the total and we subtract the negative case. So the total number of ways you can arrange 10 questions would be 10 factorial ways. You then subtract 9 factorial, 2 factorial, which is what we just calculated, to then get our answer. I'll just call this n for the number of ways. So once you do that calculation, the answer will become 2,903,040. So you take the case that you don't want away from the total to get the answer you're searching for. Now let's look at something called the permutation formula. In how many different orders can 8 nominees for the Students' Council give their speeches at an assembly? Well, based on what we have already discovered, it's going to be 8 factorial ways. Another way to illustrate it is in this manner. It's going to mean exactly the same thing, but it sets us up for a couple of different notations. So 8 factorial is the same as saying you're starting at 8 and you are going to go 8 places to the right. So that will turn into 8, 7, 6, 5, 4, 3, 2, 1. We started at 8, and then we went 8 places to the right. So we're using the entire 8 factorial to achieve our solution. Okay, so 8 factorial, which is 40320. So 40320 ways. 8p8 npn. In how many ways could a president and a vice president be chosen from a group of 8 nominees? So now we're taking our NPN concept and we're changing it a little bit, and it's going to turn into NPR. So in this case, we have 8 things, but we only need 2 places. So here, out of 8, the president could be chosen 8 different ways, but once you've chosen the president, then you would choose your vice president only 7 different ways because you've used up one of your people. So instead of 8p8, which uses all of the people, we're only using 2. So in this case, we use the format 8p2, which means, in this case, 8 times 7, which of course is 56. But if you look at the overall formula, it's proven in a slightly different way. So 8p2 is the same as 8 factorial 8 minus 2 factorial. So on the second or third page, I showed you that division turns out to be just the first two digits, because from 6 down they cancel out. And that's how we arrive back at that way of writing our permutation, 8p2. Now, applying the permutation formula, it's the same formula we just discussed. In a card game, each player is dealt a face-down reserve of 13 cards that can be turned up and used only once during the game. How many different sequences of reserve cards could a player have? So here you have to use your knowledge of cards, and you'll know that you've got 52 cards in the deck, and we are going to deal with the first 13. So this turns into 52 factorial, and then on the bottom, 52 minus 13 factorial, which is 52 factorial, 39 factorial. Many calculators will have an NPR button where you will input N, you will input R, and it will then calculate the answer for you. So this turns out to be 3.95 times 10 to the exponent 21. Thank you for listening.